So ILO defines what is exposure limit. It is the concentration in the air of a harmful substance, which does not, it is believed in the light of the present scientific knowledge, causes adverse health effects. Does not cause adverse effect, including long-term effects and effect on future generations if exposed for 8 to 10 hours per day, 40 hours per week. That is a standard working time. So which means if you keep the quantities within the exposure limits and the people repeatedly exposed to this limit will not have any adverse health effect. That is why we call it exposure limits. So there are different limits, permissible exposure limit, TLV, we will come to that. So these are the limits, we can call it as safe limits to workers. The substance normally are airborne contaminants. Today we are only going to discuss about airborne contaminants in this topic. Even though I took the example of radiation, we are here today talking because radiation will come separately one topic. So today our discussion point will be airborne contaminants like dust, fumes, gases. It is established on the basis of present scientific knowledge, which can change tomorrow. And the limit may not completely guarantee safety, but it gives some kind of reference point for us. So the OEL defined by ILO as the concentration that should not cause adverse health effects is applied to airborne harmful substance for workers 8 to 10 hours per day, 40 hours per week. No issue. It will not cause any adverse effect. And they are based on the current scientific knowledge and they don't guarantee. So we cannot 100% guarantee that it is safe, but something is better than nothing. That is a concept. So when establishing the occupational exposure limits, they consider the airborne nature, whether the substance will have like fiber can be airborne, dust can be airborne, gases, fumes, mist, etc. The scientific basis on what it is subject to change because new technology will come. They will do the basis, scientific basis. Then guidance is not a guarantee. Already told you. It's only a guidance. We cannot say it's 100%. So that means elimination is the best. If you are able to eliminate that chemical, like you are telling cyanide is used, so the management think about a replacement or elimination of that cyanide totally from the site because it's a highly, extremely dangerous product, or some kind of substitution, than thinking about OEL. OEL is we are thinking on the last, on the extreme side. So here physical chemical properties, exposure scenario, lab testing, health surveillance, all are part of setting this OEL. That is what I already told you. They will do extensive research and then they come with this OEL. It is established through national legislations or agreements, international agreements or national legislations. Competent authorities review the data to establish suitable exposure limit. They keep on reviewing it. The competent authorities are, I already told you, so many competent authorities. Safety factors account for species difference, exposure conditions, and population variability. So they already consider this, like for Asians, for Africa, for Americas, for British. So like that they consider. But again, they don't keep a standard like separate for separate countries. They keep a unique standard. Emphasize substances that can be absorbed through skin. And a table of diagram will also be given to you illustrating the OELs. So there are some OEL standards which we need to understand, which we need to refer to. The first standard we should look into is the NEBOSH 2002. We'll just see what is NEBOSH. Anybody who know what is the full form of NEBOSH?
Control of substances hazardous to health.
Correct. Control of substances hazardous to health regulation 2002 of the UK. This is very, very important for you on an examination perspective. So we can just see this. Just a minute, I will show you this. So first we will see this standard. It will be shared to you also. So you can see here, control of substances hazardous to HSE UK document, and many information regarding hazardous substances control, prevention, etc. will be given here. This is a regulation, UK regulation. When you are referring this kind of regulation, you will not get time to go through the entire content. Just go through the headings and see what is there. Okay, you cannot go through the entire regulation now, but at least see that what is the coverage, what are the things, like you can see here, carcinogens, mutagens, biological agents are covered, substances hazardous to health is covered. Then biological agents like microorganisms, cell cultures, parasites, bacteria, fungi, virus is covered here. Then the carcinogen, cancer causing substance, mutagen, it will affect the genes and it will pass on to the next generation also, like methyl isocyanate, which leaked in the Bhopal. It's a mutagen. Then there are some hazard codes, hazard warnings. You can see this will be in the MSDS. Then some categories. So these are all the things you should be interested to know about it. Okay, so just go through it. It's a long document, but just see what are the things covered. Even the cost risk assessment is very important. You can go through this cost risk assessment, how it is to be conducted, etc. Just an outline look only, because anyway during the exam you can refer it. That is the advantage of this open book exam. So this is one international guideline can be used for examination during the examination. The next one we are going to discuss is the EH40 table. This is very important. EH40 table. Okay. So we'll see the EH40 table. Now this EH40 table is the UK standard for workplace exposure limits. So during exam, you will be referring only these two documents mainly. Cost Regulation 2002 and EH40. Again, you can see this is published by HSE UK. So this will give you all the details about hazardous substances exposure limits like this. So you will get the substance name, the CS number, all this we will be discussing later. I'm just now only introducing to you to EH40 table. So you have any substance in your workplace, you want to know what is the permissible exposure limit, you can refer to this table EH40 as per the UK standard. Then we are coming to the next one is OSHA. Suppose you are working in an American company, you may have to refer to the OSHA standard. So you can note down the standard number here, OSHA 29 CFR 1910.1000. This means OSHA means Occupational Safety and Health Administration Standard, US standard. 29 means Department of Labor. CFR means Code of Federal Regulations. It is an act in USA. 1910 is not a year. It is just a number indicating general industries. Because 1926 is construction sector and 1910 is for all other industries apart from construction. And dot 1000, that is a paragraph number, we call it a section number, because that dot, if you want to see the book, I have studied this around 1000 700 pages standard, you can see, because I prepared this for my OSHA trainership program. The whole standard I had studied. This is the OSHA standard. I studied from RIT, New York. So this is 1910. You can see CFR 1910, which is a booklet like this. You can download it. It is available in the internet. We will also share you. So this standard is a very beautiful standard. Okay. And we'll just see it here. OSHA standard, because some of you may be planning for CSP in the future, or you are working in American company. So I always match with US standards also. So there is a table called table Z table. So you can see here, this table will give you an idea about the limits of all the, what is a permissible exposure limit basically for these chemicals. Okay, so this is a reference. We will come back to all this later. And then suppose you are working in India, we have Indian Factories Act stipulating this. So Indian government also has got exposure standards. So we will see that. So the Indian Factories Act, in the appendix, they are giving this. So you can see here, these are the Factories Act. And occupational exposure limits are given towards the end as an annexure to this act. Yeah, you can see here the permissible exposure limits. The second schedule of the Indian Factories Act. If somebody working in India, you can note down, it is in the second schedule of the, and it is also covered in section 41F. So you can see, mainly we generally follow this one. So what is the ppm? 8 hours 15 minutes, and normally we follow the UK standards. It is based on the UK standards. And then finally we have the ILO code of practice for this. ILO code of practice for occupational exposure standards. ILO resource is there. So international migrated content, occupational exposure to airborne substances harmful to health. PDF document, you can download this PDF. So you can see it comes like a booklet. So these are the reference materials. But during examination, you will use only that first two. COSH 2002 and EH40 table. Please note it down. The all others I am giving you just for your broad knowledge, because I don't want you to confuse when you are working in an American company tomorrow, which standard you need to follow. Anyway, ILO code of practice is just getting open. We have a ILO code of practice also. We'll see that later. Coming back, so these are the normal standards we have to refer. Anybody, any doubt on this?
Sir, one question. Actually, we are working in the Middle East, and which standard we can refer, like ILO COP or?
Depends on your, see, basically, you already have a system like ISO 45001. You already have procedures. They might have already set you these limits in your manual. If you have a HSE manual, that consultants, which standard they would have referred, they would be giving in the manual.
Okay.
Normally, what I do, suppose I do consulting, I ask the client which standard we should follow. There are options. Like in India, sometimes they tell we can use multiple. We can club with the UK standard, US standard, Indian standard. All three we will refer and we will fix a standard for that company. So that becomes the company standard.
Okay.
Somebody says, no, my client is from UK, sir. So you only set me UK standard. They will not understand anything else. Like I am doing a consultancy for in Saudi one company. Their client is this BAE Systems. BAE System, British Aerospace. So British Aerospace, they want everything in. They will not understand any other standards. They want everything in UK standards. So for them, all these limits will be set as per the EH40 table. So you have to check if you have nothing. Then for the examination purpose, right now, you go only as per the COSH 2002 and EH40 table. Refer to that. Got it? The first.
Yes, sir. Yes, sir. Got it.
Okay. So I am giving the other things as for your future reference. And you should know, like, there are different standards, not only the UK standard, but suppose tomorrow you are going to work in Aramco or any contractor of Aramco, they will not accept this COSH and EH40. They will accept only that OSHA, because Aramco completely follows the OSHA standards. So that time you as a manager or a trainer or something, whatever, you should know that this is a standard, but I have to follow that. India, we already have Factories Act, so we have to follow that in India. Then ILO is just a reference material for all of you, just to have a good reading on that. Even in ILO, anything you can use for exam. So during the IDIP exam, only use the British standards and ILO. Or not, you will not. If that is not there, so additionally you can quote. Suppose you want to impress the examiner by showing him, sir, I know apart from COSH, there is also a US standard. So additional information karke, you can write extra. So examiner, he will get shocked. Oh, he is going up to, like that you can impress. So for that, it will be helpful to you. So now let us come to the exposure limits and values now, and we will see how to interpret all these informations. Exposure limit means what? It controls the impact of hazardous substance on the workers in the workplace. Because we know every chemical, whether it is a gaseous form, liquid form, or it is a fumes, dust, mist, it will have some impact on the human body. So we have to limit it. Both long-term and short-term exposure limits are expressed at TWA concentrations. Anybody, can you tell what is TWA?
Time weighted average.
Correct.
Time weighted hours.
Time weighted average. It is basically weighted on duration, like 8 hours or 15 minutes. Basically, TWA is divided into two. One is 8-hour concentration permissible, because 8 hours is the normal shift. Then the other is 15 minutes. So 8 hours, we call it long-term exposure limit or LTEL. LTEL, long-term exposure limit. And 15 minutes we say for STEL, short-term exposure limit. Now why? Which all chemicals we need to look at short-term exposure limit? Which all chemicals we should look for long-term? Any idea, anybody? Which type of chemical?
Yes, sir. Same like H2S. Long-term exposure limit 8 hours and short-term exposure limit is 15 minutes for 15.
Okay. See, basically, first idea of giving 8 hours and 15 minutes, some chemicals, they have acute effect. Immediate effect will be there. Like chlorine, H2S. You start inhaling, the moment the ppm level crosses certain limit, you will collapse. But certain chemicals like carbon monoxide or asbestos fiber or asbestos dust, it doesn't have any immediate effect. It will affect you after 10 years, after 15 years. So for that kind of chemical, whose effect is long-term, we go for long-term exposure limit. But there are some chemical, like you said, H2S, which has got both, which will cause immediate effect also, long-term effect also. For that, we will calculate both. We will say this is the short-term exposure limit and this is the long-term exposure limit. So this is called time-weighted average. Since we are calculating based on duration, we call it time-weighted average. TWA measures airborne concentrations averaged over a specific period, 8 hours or 15 minutes. LTEL manage chronic health risk over 8-hour TWA, while STEL manage acute risk over a 15-minute TWA. This is what I was explaining to you. Is that clear? Anybody has got any doubt on this? Please ask now. Is this concept is clear? What is LTEL and STEL? Okay. So, long-term exposure limits are based on 8-hour reference period. Short-term exposure limits are based on 15 minutes reference period. And the values, one thing is there, all chemicals will not have STEL. Only few chemicals will have STEL. Most of the chemicals, they have LTEL. If not assigned, suppose X chemical, the only LTEL is there. Suppose they are saying like LTEL is 30 ppm. Now, what is ppm? I will come to that. What is ppm?
Parts per
Parts
million.
per million.
Correct. That is a unit, parts per million. What is parts per million? Anybody can explain? Okay, ppm is parts.
1 part of 1 million of 1% of a gas.
Correct. In simple way, if you are using a gas monitor, that gas monitor is sucking atmosphere gas. We call it ambient air. It is sucking. It will take 1 million molecules of air, whatever it sucked, atmospheric air, and it will analyze. So when it says 30 ppm, out of the 1 million air molecules, 30 molecules were carbon monoxide. That is called parts per million. Anyway, in a simple way to understand. Suppose LTEL is 30 ppm, but STEL is not given. STEL is not given. Then what do? You just multiply this by 3. That will be the STEL. So 90 ppm can be taken as STEL if it is not specified. So 3 into LTEL is equal to STEL if it is not provided, but you want to know about it. So the units already we have explained. One is parts per million, that is for gases. For dust, you use milligram per cubic meter of air, which is something like this. So in one, yes, Vinith?
Sir, actually, for the long term is 30 ppm, for example, and into 3. So this parameter, like into 3 for short term, means it is a like guidelines or
Yeah,
like
it is a guideline.
Okay, okay.
It is a guideline by these standards, whichever we saw. They are that standard says that.
Okay, okay.
Yeah. So I will be sure, maybe while going through the standards, we can see that also where it is written. We'll see that.
Okay, okay.
So either if it is gas and vapor, the unit will be parts per million. If it is particulates, dust particulates, it will be milligram per meter cube. For fiber, we will see that it is fiber per cc, cubic centimeter, something like that. Countable fibers by cubic centimeter of air, something like that it will come. So milligram by meter cube is nothing but in 1 meter cube of air, in 1 meter cube of atmospheric air, how much milligram of contaminant was there or permitted? Yes, Zahid?
Yes, sir. Good morning. Yeah, I want to clear that it's decide STL and LTL. It is both decide on properties of that chemical or gas and ppm both.
See, I told that.
Can we decide based on both or something else?
No. See, LTEL is nothing but it is a long-term exposure limit of the same. Say, for example, you go to H2S.
No, I know, sir. I know that. But I want to clear that how we will decide for STL and LTL. I think it is based on how much ppm and the properties of that
Yeah.
chemical
Yes,
or
yes,
gas.
yes.
Both can be considered.
Both will be considered. Both will be considered. We are coming to that calculation and all now.
Concentration level.
Yeah.
Yes,
We'll come
yes.
to the calculation. We'll come to know. So for any particulates, it will be milligram by m cube. For fiber, it will be number of fibers per cubic centimeter. Fiber per cc. So what is LTEL? LTELs generally we identify to manage chronic health risks associated with the prolonged exposure. If our employees are continuously exposed for a long duration, up to what concentration can we expose them? LTELs are based on 8 hours. Some fluctuations may be allowed below the limit as long as the 8 hour average stays within the LTEL. Like 1 hour, 2 hours. Suppose first 1 hour it was little higher than the permissible limit, but the next hour it came down. So we are only looking at the average. But if you think that this gas will have acute effect also, then we have to, that is why they set the STEL and LTEL. So anytime the STEL increases, the alarm will ring because that is very dangerous. We will be seeing all this now. STEL for acute health risk from a brief exposure based on a 15-minute time-weighted average. Managing STEL for substances without assigned limits using 3 times the LTEL, we have studied that. So exposure limits are in place to control the effect of a substance, number 1. Both long-term and short-term exposure limits are expressed as TWA. This means that measurements are taken and the airborne concentrations are averaged out over a given period of time. Okay, this all we discussed. So this is also known as well. In UK, they call it as workplace exposure limits. In US, they call TLV, threshold limit values. In some European countries, they call indicative limit values, ILV. I think in France, they call it a MAK value, or Germany, they call it a MAK value. So different countries has got different nomenclature, but normally you just don't confuse. All of them are talking about the same thing in a different way. So in UK, it is well. If you understand this two is enough. In US, it is TLV, threshold limit value. In UK, it is well, workplace exposure limit. So in the UK, the HSC have established, HSC, Health Safety Executive, which we have just seen, workplace exposure limits, and it is defined as the maximum concentration of an airborne substance averaged over a reference period to which employees may be exposed by inhalation. That is what is given in the COSH. We have already seen the COSH, the regulation. The substances for which the workplace exposure limits have been assigned under COSH are listed in EH 40 2005, which also I have shown to you. No internationally recognized global standard. Every country can follow their own standard. There is no unique standard. That is another minus point for this. US will have their own calculation. UK will have their own calculation. France will have their own calculation. If our country doesn't have, we have to just borrow from somebody. Like in India, we just follow the UK. We don't need to invest more money and find out the same thing. We just get it from UK and publish it. Finish.
No any guidance from ILO on the standard?
Yes, ILO code of practice is there. I have already shown to you. ILO
That is
COP.
the international law, no? That is also
No, but they are
international.
not giving the, see, ILO code of practice only giving you idea how to set the limits. What is the limit? They are not telling.
Okay, exactly they are not.
They are not giving you that value, that 30 ppm, 20 ppm, ILO will not give.
Okay.
ILO will give you guidance how to establish that. Got it? Like I used to explain the difference between Act and standards. Act will say scaffolding should have an appropriate fall protection system. But standard will tell what is appropriate, what is the guardrail, what is the height of the guardrail, what is the middle, same thing. ILO will never give you values. ILO will give you only guidance.
Only Act.
Based on the guidance, countries will develop the standards. That is why it varies between countries. We will be seeing all this now. So it is important to select the correct OEL for the country in question. If your country has a OEL, we have to follow that. So now you are in India, suppose. We have to follow the Factories Act Schedule 2, whatever I have seen that, because it is already published as an act. Maybe we can go for superior. We cannot go inferior. We can go for superior act, superior standards, but not inferior to that. So in UK, it is workplace exposure limit. In USA, it is normally TLV, but TLV is further, they say permissible exposure limits. And then they club it at threshold limit values. So there is a TLV TWA, that is time weighted average. TLVC, that is ceiling limit. TLV STEL. Now what is TWA? 8-hour concentration. What is STEL? That is 15 minutes. What is TLVC? That is a question. Suppose they will say like, for example, 8-hour is 30 ppm. Okay. And suppose 15 minutes is 90 ppm or 80 ppm or 90 ppm. Then there will be a ceiling limit. Maybe they will say like 150 ppm, which should never be crossed, whether it is short term or long term. That is the upper limit beyond which your employee will be in trouble. So they call it TLVC, ceiling limit. Okay. Beyond which at any point of time, concentration should not go ahead. So France, they call it VME value, Germany MAC value, European country ILV. So don't confuse. These are all, they are talking on the same topic, but indicating in different way. United Kingdom, workplace exposure limits established by HSC and legally enforceable. United States, PL by OSHA, which I have shown to you, the table, Z table, which is by, there are 3 tables, Z1, Z2, and Z3 for particulates. Z3 is for dust and fiber. Z1 all gases. Z2 straight, whichever has got little higher values like that. So the main table is Z1 table and Z3 table. And they are American Conference for General Industrial Hygienist. This is the body, research body, setting these limits. American Conference for General Industrial Hygienist, ACGIH values. So EH40. So in your book, by mistake, they have put ER40. So that is a mistake. We will be correcting it now. Actually, it is EH40. Please amend it. In the textbook itself, amend it. Or just understand that it is EH40. Workplace exposure limits, which we are going to see it now. So it is like a table. So I will go to the table and explain to you EH40, because for your exam point of view, this is very important. Back low. Let me connect my battery. So we'll go and see how to use the table. So this was the ILO code of practice, which I was showing to you. All these copies you will be getting. So occupational exposure to airborne substances harmful to health. This is the ILO publication. Anyway, we are going to that EH40. Okay, so this table is very important for you during the exam also. Now, In this table, you go down, 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 it will come like contents will come. Then certain things I will just explain to you. Some revision is coming up on this, something like that. Some exceptions. So they will tell what is well. So they say long term for 8 hours and short term for 15 minutes. These are all as per the guidance of the cost regulation and who is affected and all. And some abbreviations you need to understand. If they are giving B, some notations are there. You can see here annotations. BMGV means biological monitoring guidance values. So they have done based on some biological monitoring. If they have indicated CARC means it is a carcinogen. It can cause cancer or heritable genetic damage. That is a notation given to some chemicals. This indicates some biological, cell damage can happen. So something affecting biology of the human body, that chemical, if it is written BMGV, you have to refer to another table too to understand what are the biological problems affected by this chemical. If they write SEN, that is sensitizes, causing asthma or respiratory problem. And SK means skin notation. That means it is harmful to skin or it can cause toxicity by absorption through skin. So these are all annotations given along with the chemical. We'll see that now. So this is the table. For suppose, let us see the common chemical one is carbon monoxide. So it will be in, suppose you want to see what is the TWA for carbon monoxide. Okay. So you go alphabetically or you would do Control F, search here carbon monoxide. It will come. See, it is immediately coming like this, carbon monoxide. So now you can see here. The first thing is CAS number. There is a number called a CAS number. Anybody know about this number? Okay. See, CAS means Chemical Abstract Service Number. All of you note it down because this information you will not get anywhere. CAS number is Chemical Abstract Service Number. Now, what happens like when you buy a car, you have to immediately register it with the RTO, registration, transport registration organization, and you get a vehicle number, which is unique number. In your country, your vehicle only will have that number. So it becomes easy for identifying your vehicle. If it is doing any violation, traffic violation, they capture the number and send you the challan. So it is a unique identification number. This is given to the chemicals. There are some register kept for registration purpose. So it is like your vehicle registration number given to this chemical. It is a unique number. It will not go to any other chemical to identify the chemical. That is called CAS number. And where you get it, even in SDS, in your safety data sheet, you will get it. Okay, so carbon monoxide CAS number is given here. And then what is given here is the 8-hour TWA in ppm as well as milligram by meter cube. So in ppm, it is 20 ppm. So you can see here, carbon monoxide as per EH40, 8-hour TWA is 20 ppm. Yes, Zahid?
This CS number is given by whom? HSC UK or?
No, it is an international registration form for chemicals. Okay. Yeah, it's an international body. Now you see here it is written 20 and bottom it is written 30. Why? Because that is allowed in tunnels, mining and tunneling industry only. So you will see towards the right it is given. This limits applicable to underground mining and tunneling because they are little bit allowance they are giving. So which means you are working in an open area, you are allowed 20 ppm carbon monoxide, 8-hour TWA. If you are working in mine or tunnel, 30 ppm is allowed. So that comes to 23 milligram by meter cube and 35 milligram per meter cube. Just they are converting and giving to you in milligram by meter cube also. Suppose somebody's that gas monitor is calibrated to that. Yes, Francis?
Sir, as you said that the 20 milligram is for open space and the 30 for mining in covered area down below. So it should be vice versa, right, sir?
This is called allowance. This is called adjustment.
Open air is also there blowing.
Yeah, I will tell you, this is, see, this is, I will tell you, to maintain lesser than this is very difficult in this situation, that situation. So they are just allowing it. Allowance is given in only that particular situation. And still they have considered it, it's not that harmful to the human body. That is why they are allowing. You got it?
Okay, sir. Okay.
So there is some allowance given. So they cannot be so much strict where work itself is not possible to happen. So this allowance is given at certain places. Even after due consideration, maybe their job rotation, they will be suggesting more job rotation or more. Yeah, Sayuj?
Sir, in confined spaces, we can use the highest level, right? 30, suppose we are taking 23 and 35, then...
No. See, here, very simple. What they have said, only to underground mining and tunneling industries. That's all. Not in any confined space.
Oh, okay, sir.
They are very strictly said only for underground mining and tunneling industries only. And that too, they have allowed only up to 23. Now they might have revised it also. So this was an exception given by the government. Okay? So let us not discuss too much on, let us only discuss on the first value. You got the point? So here conditions are set here. You can see the conditions. So here 20 ppm for 8-hour TWA, which is 23 milligram by meter cube, and 100 ppm for a STEL. STEL is 100 ppm. Allowed. And they are saying it has got biological, some index is there, some effect will be there that you have to refer to another table. So these values we got, you all please note it down. All of you note it down because I am going to do some problem based on this. So carbon monoxide, LTEL is 20 ppm, don't take milligram by meter cube, we'll say only 20 ppm and 100 ppm STEL as per the EH40. Suppose anybody want to check, okay, let us say hydrogen sulfide. For hydrogen sulfide, H2S. So here we type hydrogen sulfide. Here you can see hydrogen sulfide. CAS number is there. For some chemical, you will see CAS number is not there because it is not at allotted. Maybe some reason revision is going on. So we have to accept it. Now, where CAS number will come into handy is, suppose there is a chemical leak. If you go to the SDS of chemicals, you will see a ChemTruck number. ChemTruck means Chemical Transport Emergency Code, ChemTruck. There is an international number given in the SDS. If that chemical is leaking, you want some help from outside. How to deal with that spill, or you can call that number. Some of the number are toll free, internationally toll free. 24 hours working. And if you ask them, say, I need your help. One chemical is spilled here in my site. They will first ask, tell me CS number. They will not ask the name. Because different country name may be different for chemical, same, but they identify the chemical through the CS number. That is why that CS number they ask. And once you set the CS number, they will put in the computer and they will give you assistance to deal with that leak or spill, whatever it is. That is why this number they are mentioning here. And that is why this number is mentioned in the SDS of chemicals. Now here ppm 5 ppm is the, for H2S, 5 ppm is the LTEL and 10 ppm is the STEL. 10 ppm is the STEL value. for hydrogen sulfide. Okay. Fine. So same thing when we come to the Z table, there may be slight difference. So first of all, in the Z table, you will find mainly, you can see the Z1 table is here as per the OSHA. CAS number is also given here. And very light, the next thing is the ppm. ppm level is given, milligram by meter cube is given. This is only PEL, permissible exposure limit. Okay, I'll tell you about STEL value and I'll tell you. So ppm means this is the permissible exposure limit for 8-hour TWA. Please understand that this acetaldehyde 200 ppm and milligram by meter cube also 360 given. That means this is, you must understand, this is, see in Z table they don't give separate like EH40, they have given separate STEL separate, LTEL separate. Here they will not give like that. Here first what you see is the permissible exposure limit, that is 8-hour TWA. Then you see they put C means this is ceiling limit. Ceiling limit means it should not cross at any time. Like 10 ppm for allyl glycidyl ether. You should not cross 10 ppm or 45 milligram per meter cube anytime, whether it is short term, long term, it should not cross. So that is why they have put it C value, ceiling limit. Then you come down. See, if there is a STEL, they will mention it like this. 1 ppm is the STEL, 5 ppm is the permissible exposure limit. See, 1 ppm is the normal, 5 ppm is the STEL. So 1 ppm is a 8-hour TWA for butadiene and 5 ppm is the STEL. They will indicate the STEL after the LTEL. This is the STEL value. As I told you, in OSHA, they are not giving STEL for every chemical because they already told you, you multiply by 3. Only specific substances, they are giving you something little more than 3. Like here it is 5, which is more than 3, then they will mention it here. Like up to 5 ppm you can have STEL. So butanone, it is given 200. That means STEL is 200 into 3. But here it is more than that, so they are giving here. Okay, so this only this much you need to understand. Now they have said here blank 2. Now here for, okay, let us first identify carbon monoxide. Now you see there is a slight difference here. Now you see, as per EH40 UK, 8-hour TWA for carbon monoxide was how much ppm?
20.
20. But in US, 50. See, their difference can country to country, they can differ. This is the one of the disadvantage of this. We cannot question them. They are allowing up to 50. They said it is okay, up to 50 is okay for them. So if you multiply by 3, what will be the STEL? 150.
150. Here,
There it is 100.
100.
Now, that is why UK standards are very, very stringent than US. Please understand. UK standards are very, very stringent than US. US is slightly, I can say much, they think more on practicality. That doesn't mean that they are unsafe. They are also safe. But UK, they always keep stringent values because they don't believe in the people. They say they will cross the limit. But US says, I will ensure that they will not cross the limit because the OSHA enforcement system is very, very tight than the HSE UK enforcement. Enforcement wise, they are very strict. So they are keeping something more. So please understand there will be differences like this. Okay. But whichever standard you are following, you have to just follow it. We are not a question. Then some chemical like carbon tetrachloride, it is given bracket 2. That means you have to go to table 2. Z2 it will be there. That is why they are just to put a bracket 2. Okay. So there is a Z2 table. So if you look at here, maybe hydrogen sulfide may not be here. It will be in Z2 table. Now Z3, you can see here, coal dust, respirable dust, coal dust. Now you can see go to Z3. So this is separately mentioned in the Z3 table. So there is a Z1, Z2, Z3 table. You Google, you will get it. Okay. This is how to interpret the tables. So I have explained this to you. Yeah, these all things are explained. Yeah, now how to calculate TWA? How to calculate the long-term exposure limit? The formula is very simple. It is not very complicated. So the formula C1 T1 plus C2 T2 plus C3 into Cn Tn by 8. That means concentration 1 multiplied by duration 1. Suppose you are starting monitoring from morning. Maybe your working time is 9 to 5, 8 hours. Your working time is 9 to 5. So morning 9 o'clock, you are starting now. So up to 10 o'clock, 1 hour. Suppose you are monitoring carbon monoxide. There was 30 ppm for 1 hour. So 30 into 1. Suppose that 30 is continuing for another 1 hour. That means 2 hours, 30 is continuing. So 30 into 2. That is C1 into T1. After that, it increased to 50 ppm for 1 hour. So plus 50 into 1. Like that. What is the continuous concentration for the duration? You will multiply it. Like that, you keep adding you up to 8 hours. Divide by 8. That is the average. We'll see now. Now, this is a problem. All of you can just note it down. Please note it down. An employee is exposed to carbon dioxide concentration of 5,300 ppm. Sorry, it is 5,200. Sorry. Yeah, there is a mistake in the question. Please correct it. You make it 5,200. 5,200. All of you note down this question, please. It is not in the book. An employee is exposed to carbon dioxide concentration of 5,200 ppm for 2 hours. So that means 9 o'clock the work started. So 10 o'clock to 11 o'clock. That means 2 hours. The concentration was 5,200 ppm. Then it increased to 3,500 ppm for 3 hours. It was 11 to 12, 12 to 1, 1 to 2. It was 3,500 ppm multiplied by 3 hours. After that, it raised to 5,125 ppm for 3 hours. So total, you will see they have taken the value for 8 hours. 2 plus 3 plus 3. So it comes 10,600 ppm plus 10,500 ppm plus 15,000 divided by 8. It comes to almost 4,559. So carbon dioxide. Now, if you go to Z1 table, so this is the TWA, time weighted average you got. So when you go to the Z table, this is as per the OSHA only. I will come to whether you refer here or there, problem is same. So when you go to the Z table, you identify carbon dioxide. Yeah, you can see carbon dioxide here, 5,000 ppm. Allowed permissible exposure limit is 5,000 ppm for carbon dioxide. So you come back to your problem. You come back to your problem and you see you got 4,559, which means your people are safe. You have not crossed the limit. So this is how to calculate it. Here we went to, let us go and see Z table. Suppose the same problem comes to you. There you cannot go to OSHA. You have to go to EH40. So let us go to the EH40. EH40 table. And here we say carbon dioxide. So you can see here also they are matching 5000 ppm. You can see here carbon dioxide 5000 ppm is the permissible exposure limit for long-term exposure limit. Sorry, here it is LTEL. Long-term exposure limit is 5000 ppm. So our employees are safe. We don't need to do anything. If they are exposed, we have to go for control measures. Whatever control measure, maybe respirators, maybe we are going to do some elimination, substitution, engineering control, and all these things. Up to here, anybody, any doubt? Up to here, any doubt? The calculation is clear to all of you. Please go ahead. Go ahead.
Which monitor we use to get this figure? Because what we are using is set for 25 ppm.
Sorry?
The monitor for monitoring.
You can calibrate. You have different gas monitors calibrate to different values, right?
But in our organizer, the monitor what we are using is set for 25 ppm.
So that means after 25, it will give you alarm.
It gets alarm, yes.
Maybe your company standards is requirement is that. That's why.
So usually the gas monitor.
Which gas you are telling 25 ppm? Is it carbon monoxide?
That is for carbon monoxide. So here it is carbon dioxide.
This is carbon dioxide. This is carbon dioxide.
Oh, sorry.
Yes.
Sorry.
So people get confused.
Oh, okay, sorry. So this is carbon dioxide. For carbon monoxide, it will cross 20, it has to, because 20 is the limit for carbon monoxide. Correct? You got
Carbon
the point?
monoxide, the alarm will start raising 25 ppm usually in normal.
Why 25 ppm? Because your allowable is how much? As per UK, as per EH40, yes. Allowable is 20 only.
20 only, but the alarm will start in 25. And the second alarm will be on 100 ppm. I think.
Okay. That is for the STEL value.
STEL value.
Exactly. Now you are understanding why that 25 alarm is ringing, why 100 alarm is ringing. So now you can correlate with why it is ringing at, why it is set at 25. So please understand this is for carbon dioxide, not monoxide. So carbon monoxide means this is too much. 5200 will be very high for carbon monoxide. This is carbon dioxide. Okay, right.
I had an experience when working close to the ground flares.
Yeah.
There you can experience the carbon monoxide.
Okay.
On the ground flare areas. So
flare.
usually it will, ground flare. Usually it will, when you are working close to that area, sometimes due to the air, you will get the monitor gives alarm frequently for this 25 ppm. Yes, sir.
Yes, because it will be that concentration when you go to that area.
Yes.
Correct. Exactly. So now, sometimes shift may not be 8 hours. For every company, some employees may have to work for 10 hours, sometimes 12 hours. So how to adjust this value? Okay, 8 hours is international protocol, but we cannot guarantee that every employee working only 8 hours. Somebody. So how to adjust this? There is a formula, all of you note it down. PL or TLV in, like, for example, carbon monoxide 20 ppm. So if carbon monoxide is 20 ppm is the permissible exposure limit as per the EH40 into 8 divided by actual. Suppose your person is working for 10 hours. So 160 by 10. Now you see it will go down. 10 hours is the actual shift. So that is equal to 16 ppm will be the permissible exposure limit if the person is working for 10 hours. As the duration increase, you will see the quantity will decrease. So this is one formula, you can note it down. This is shifting of PEL or permissible exposure limit, or 8-hour TWA, like LTEL. So your LTEL given for 8 hours was 20, but your person is working for 10 hours. So 20 into 8 by 10. So you will get the revised STEL value should be 16 for that person. So that person's gas monitor will be calibrated to 16. If it cross 16, it will start giving you the alarm. Anyway, so there is another, these are the problems which come in CSP exam. So if you are interested, you can note it down. OSHA has established PEL of 5 milligram by meter cube for respirable dust. What would be the modified PEL for an employee working for 12-hour shift? So 5 into 8 by 12, which comes to 3.3 is the revised. What I have explained, they are explaining in another way. Whether it is ppm or milligram by meter cube, that doesn't matter. But just you understand what is the PEL for 8 hours, multiply by 8, divided by the actual shift hour. If he is working for 12 hours, 12, you will get a revised one. You can see from 5, it has come down to 3.3. Revised PEL.
Sir, I have remember there is another method called brief and scala method.
So many methods are there. We are teaching the simplest methods.
Yes, to find the TLVs.
Correct.
That is also another, because
Yeah.
you know, it will give the reduction factor, exposure of the employee to the workplace.
Correct.
So that can be also used.
Yes, yes. If you have that, just share with me.
That was the formula for reduction factor is equal to 8 divided by the hours work into 24 minus the hours work divided by 16. Correct. That is so a little bit complicated, so they don't go to that area. That is very complicated calculation. Yes, I have worked on this before, so to get some examples of how we calculate the TLVs for
understood. That is very deeper. You have gone very deep.
Usually developed for 8 to 10 hours work per day. Correct. Yes. So this is in a very simple way how to calculate, and mostly that is the UK system what you're talking about. This is the US system. But for exam purpose, this calculation will work out. What we are studying now, that will work out. So, in DIT, we need to use these things, sir? Yeah. So we have to apply the formulas. Yes. Yes. Okay. Sometimes they can give you just a question like your employees are exposed to like this many hours, this much ppm. Now you just tell whether calculate and advise your employer accordingly. So when you need to at least put this formula, calculate, compare with EH40 and tell if it is exceeding, you have to comment on that as per the EH. That time calculation formula is this, but reference to EH40. Whatever formula, only 2 formula I taught you now. One is the time weighted average. Now for 15 minutes, it will be 5 minute, 5 minute, 5 minute. Like they will give you the value for first 5 minute. So you multiply by that 5 minute, then divide by 15. So first 5 minute 10 ppm. So 10 into 5 plus next 5 minutes 15 ppm. So 15 into 5. Next 5 minutes 20 ppm. So plus 20 into 5. 5 minute value they will give divided by 15. That is a STEL. So what value you get, that is a STEL value. And compare with EH40. So then you will understand whether it is safe. If it is safe, you tell, okay, my employees are safe. I don't need to do anything. So here everything multiplied by 5 minute, 5 minute, 5 minute divided by 15 minute. That is the STEL, short-term exposure limit calculation.
Standard unit is hour or minute?
Minute. Hour is 8 hours. For LTEL long term, we always put into 8 hours. But here for STEL, we go for minutes, 5 minutes. So
Sir,
you
again, this STEL, it's 5 minutes or 15 minutes?
divide by 15. Every 5 minutes value will be given to you for calculation.
Okay.
First 5 minutes, or they will say first 10 minutes, this was the value. Then last 5 minutes, because calculation overall is 15 minutes. Na?
Okay. So that one is divided by, okay,
15.
got it.
That is
Okay.
that is
15
why it
divided
is-
into, okay.
That is why it is divided by 15. Here it is 15 minutes.
Yes. Oh, got it.
Anyway, calculations come very rarely, but as an applicable factor, you also should know, okay, if it comes out, I'm going to apply it. So this I have taken like TLV mixture.
Reference
Suppose you-
for this calculation is from OSHA.
Yeah. The formula
is-
works out. Formula works out for any, don't worry about the formula. Formula is same, whether it is UK standard, US standard. Only when you are comparing the final value, you compare with EH40. You got the point?
Yeah.
Formula, this formula is international formula. Don't worry about it. Or they
Results
may
should be compliance. The results should be compliance with
EH40. Yeah, because it is a UK exam, your result will be compared with the EH40 table. This I am just additional knowledge I am also giving you, like if there is a mixture of different chemicals. So this 1910 1000 D2, C1 divided by L1 plus C2 divided by L2 and Cn, this is simple as that. You can see here, one substance called B, the total exposure for 8 hours was 500 ppm. For substance C, the total exposure was 45 ppm. For substance D, now all these substances are in same workplace. You have carbon monoxide, you have H2S, you have carbon dioxide also. For example, I am telling, one employee is working, you are doing air monitoring, and you are finding that there is a presence of H2S also, there is a presence of carbon monoxide also, and there is a presence of carbon dioxide also. So your 3 substances you are at a time monitoring. You take all the 8-hour exposure of 3. Okay. And then you know what is the PEL as per EH40 or as per OSHA. So here for substance B, PEL is 1000 ppm. This is an indicative, just an example I am telling. For C, it is 200. So what do? You divide by that, like 500 divided by 1000 plus 45 divided by 200 plus 40 divided by 200. So total it comes to 0.925. The interpretation is, if this value, cumulative value we say, if it is less than 1, it is safe. You don't need to do anything. So in this case, the unit, individually you are checking, that is different. Individually you are checking 8 hours, 8 hours. This I am talking about mixture. So you want to check whether there is any synergetic effect to my employee. Then this value calculation, this is just out of the syllabus I am telling you, this is just a CSP calculation. Because in between I am just orienting you for CSP also. In CSP this calculation will come. So this is like you have a mixture to calculate. There's nothing for your exam, just for your knowledge purpose. Tomorrow, even workplace, you want to understand this. This is the formula for that. If it is above 1 means it is dangerous. You have to take control measures. So just general knowledge only. Don't break your head for exam. It is not going to come. Anyway, so from here, I just want to go for a break. So it is already, we crossed 1.5 hours. Yeah, so we'll go for a 15 minutes break. Yeah, we were here. Moving ahead, you can see here one graph. Now what it says, you see here, the x-axis is the duration and the y-axis is the concentration of the substance. So you can see here up to 8 hours is mapping. This is the result we get from the gas monitors. Now it's a nitromethane. They are just evaluating the presence of nitromethane, and the LTEL is 100 ppm. Long-term exposure limit as per the EH40 table is 100 ppm. So you can see that duration, that 2 hours to 3 hours, almost 1 hour, the concentration has crossed the LTEL. But if you look at the average, it is within the LTEL, so there was no issue. Okay, but it has crossed. Just for 1 hour, it crossed the LTEL and went up to 175, 170, something like 175, something like that. So it reached this level, peak level. But overall, if you look at the 8 hour, it is below the LTEL. So on a LTEL point of view, there was no issue. But what is a STEL? We have to check. So when we map the STEL is 150 ppm. So for a limit for about 30 minutes, the STEL is violated. So there is an issue here. We have to investigate. Why? Because more than 15 minutes, that is up to 30 minutes, it went to 170. It went up to 170. You can see 175, sorry, up to 175 ppm. So this is 175 ppm. More than 30 minutes, it was violating the STEL. So this is not acceptable. So on a STEL point of view, we have to investigate this case, why it was high. So if there is any issue, we have to cover it. And we have to analyze both. If on a LTEL, it was okay for us. When we take 8 hour average, it was okay. But when we come to the STEL, there was a violation. So this way we need to analyze. So ILO code of exposure limit, I told you, this is a guideline for the whole world. Code of practice. Ceiling means is a concentration in respiratory air which must not be exceeded at any time. Permitted excursion. Permitted excursion means amount of excursion beyond the time weighted average which is considered permissible by the competent authority. Like you have seen the EH table, EH40, for carbon monoxide 20 was normal, but they have excursion value of 30 or 40, which you have seen that for tunneling and mines. That is called excursion, permitted excursion. You are giving some allowance by competent authority. We are not giving. Some competent authority is permitting them for that excursion. Short-term exposure, 15 minutes. Time weighted average, 8 hours. So these terms, we have already studied that. So the Z table, we have seen that. 1910 section 1000 Z table, we have seen this. Now safety data sheet. What are the informations we get from safety data sheet? We have to check that. So you can see here, normally safety data sheet, how many sections are there in a safety data sheet? Anybody? Like section 1,
16.
section
16.
Yes, minimum 16 sections are there. Very good. So here you can see what I told you. What is GHS and all, we'll see later. This is for carbon monoxide safety data sheet supplied by Air Gas Limited company. So you can see here 24-hour telephone line. So you can see SDS number, address of the manufacturer, 24-hour telephone line. This is what I told you, that if you want any assistance, you can call it. But is it international? I don't know, because they have not given international. Normally they give international some number they will give. And you can see this, basically I brought it to show you where this permissible exposure limits will be this. SDS as such, we are studying in another topic. So here I brought you to show you that, see, what is this gas? So the CS number they are giving is 630080. Carbon monoxide 100%. That means this cylinder has got 100% carbon monoxide. There is no other mixture. And this is the CS number. Then they will give you the PL value. Now you see here, exposure control. So carbon monoxide, California PL. California, in US, every state has got their own PL. Okay, United States, they like, so they are manufacturing in California. So they are giving California PL 25 ppm for 8 hours. And ceiling limit is 200 ppm. Now you understand what is this. So the state of California has set a PL for contaminants as per the table AC1 in United States. But if you look at the ACGH value, I told you American Conference for General Industrial Hygienists, TLV, which is applicable for the whole United States. They are keeping TWA again 25 ppm for 8 hours. Or 29 milligram by meter cube for 8 hours. So same thing, the California state also follow the ACGH value, same 25 ppm. And they have put a ceiling limit of 200 ppm. Now you see OSHA. OSHA is slightly, allowance is more. OSHA TWA 35 ppm as per the OSHA. Okay, which is 40 milligram per meter cube. So this can vary. That's why I said there is no unique value. This can vary state to state. This can vary country to country. But if you look at the SDS, that can be taken as the final value. So the best thing for you is to refer to the SDS and your country's law. If the country in which you are working has got their own act limiting this exposure limits, that should be the top priority. Now see, ceiling limit is 200 ppm. Then you have NEOSH. NEOSH is giving TWA 35 ppm for 10 hours. You can see here. So OSHA PL is 50 ppm for 8 hours. So like that they will give you. So at least you can interpret these values now. That is very important. You know what is California PL, what is ACGH value, what is OSHA PL. So here, since it's all American, if it is a UK product, they will give you straight away EH40. Posh 2002 EH40, this is the value. If it is a UK product. So in SDS, this exposure control area, you will be able to identify and calculate very easily after this topic. That is why I took you to here. So, comparison. United States, that is why I said the results from biological monitoring are compared to biological limit values outlined in the control of lead at work. There is a biological values which is given in the US. OSHA permissible exposure action limit is 30 microgram per meter cube as 8 hours TWA for the lead exposure. So just an example is given. There is something called action limit. Action limit is a concentration of a substance that indicates when exposure to harmful substance has reached a level that requires some actions to mitigate the risk. So if they mention 30 microgram per meter cube, milligram per meter cube, not micro, milligram. So action limit is 30 milligram per meter cube as 8 hour TWA. You have to start your actions. The moment it crosses 30 milligram, you have to start taking actions. Whereas, what is the maximum allowed is 50 milligram per meter cube. Fiber per cc, I told you this. Cubic centimeter or centimeter cube. So this is for asbestos, I think. Yeah. Yeah, asbestos. You can see here, asbestos exposure limit. And as I told you, asbestos is always given in, this is 0.1 fiber per cc, there is cubic centimeter. And excursion limit, the maximum is 1 fiber per cubic centimeter, averaged over 30 minutes. So beyond that, they cannot go. So this is averaged over 8 hours. Permissible exposure limit. These are all sampling, some work given to you. So what is exposure monitoring? Exposure monitoring is the process of determining the extent of worker exposure to hazardous substance through inhalation, ingestion, or absorption. Purpose is to assess whether exposure is adequately controlled or not. Otherwise, if you don't measure, you don't monitor. If you don't monitor, you cannot control. So as per the cost regulation 6.1 and 7.1, you can note it down. Under the cost regulation section 6.1 and 7.1, employers must conduct a thorough risk assessment and adequately control exposure if it cannot be prevented. And this is exclusively for asbestos. Very dangerous. So there are some people doing this. Actually, big industries, they will have somebody called industrial hygienist or occupational hygienist. They are the people actually doing exposure control monitoring, not safety officers. So it is actually the duty of industrial hygienist to do this, all these comparative analysis, studies and all this. What they do, they are supposed to identify the health hazards from those chemicals which is available. They have to do the measurement. They are the people to do the evaluation, calculation. So they can do it by dosimetry. Dosimetry is the personal dosimetry is nothing but calculating the amount of contaminant which has been inhaled. And then evaluation. They are the people going to compare whatever we studied till now. In-depth study done by the industrial hygienist. So they know all this. They will compare it to the international values and what control measure is to be taken. So anybody, can you just explain in your organization how this whole thing works? Is there industrial hygienist available or you people are doing by yourself? Yeah, please.
There is an industrial hygienist is there and he is doing the what you are saying, exposure assessment, not only about the chemicals, he is also doing the noise, other exposure assessment.
Vibration.
Also the ergonomic assessment they are doing.
Exactly. So in small organizations, you will not find such a kind of expert people. So that time, sometimes we may have to, but we have a limited exposure, like a safety officer or a safety manager. We have very limited competency on this area. But this industrial hygienist, they have deep competency in this area. They can do this analysis very easily. So there are some, what is the role of health and safety professional? Our role is documentation and recommendation, basically. We have to ensure that everything is documented and the recommendations are being implemented. What recommendation or what observation industrial hygienist is doing, they have to be properly documented, and whatever control measure that industrial hygienist is suggesting, it is to be implemented. So substance identification, suppose there is a smell, abnormal smell during your inspection as a safety officer. So immediately you have to alert the industrial hygienist that there is some abnormal smell coming in this area or some abnormal dust settling down. So that identification, that risk assessment is to be done by us. Routine monitoring and legal compliance. So all this monitoring frequency, we have to comply with that. Like health monitoring of the employees, maybe once in 6 months. We have to comply with that. Or the other monitoring things, workplace monitoring and measuring, shift patterns and exposure supervision. So we have to guide workers on shift patterns and all the monitoring procedures, whether they are working for 8 hours, whether they are working for 10 hours. So accordingly, we have to evaluate and tell the industrial hygienist about this. Then there is a document you all can note down. That is HSG 173. Please note it down, this document. This you can easily get it from HSE UK website. If you just type HSG 173, you will get it. This document gives some idea about monitoring strategies for toxic substances. Please go through this. The basic philosophy of this document is do not measure unless you know what you are measuring and what you will do with the result. So this document will give you an idea on this. And also, if you go to, you just note it down, go to HSE UK website and type methods for determination of hazardous substances guide. Methods for the determination of hazardous substances guidance. So you will get some guidance here, MDHS guidance. This just to do referencing, and if any question comes in exam regarding hazardous area monitoring, you can take help from these documents. Many of the things we are already covered, so you will understand this. So it is standardized, reliable, reproducible, accurate, tried and tested, HSE approved guidances. These are all. So for exam purpose, you will use these guidances. And any future also. If you want any guidance, you can take it from here. Then NEBOSH, I just told you, it is completely American. So during exam point of view, it will not work. But they do a lot of sampling. You can visit their website also, NEBOSH. It is a very important organization in the United States. They do sampling or biological sampling also, and also exposure to health hazards and all these things. So NEBOSH gives a lot of standards. And ISO, if you want to know about ISO standards, these are the ISO standards. ISO 1317. If you Google, you will get it. PDF. ISO 13137 PDF, you will get it. Workplace atmosphere. Pumps for personal sampling of chemical and biological agents, requirements and test methods. And another ISO 160172. That is indoor, ambient and workplace air sampling and analysis for volatile organic compounds. Something like diffusive sampling and all. So we are going into workplace sampling now. So what is sampling? Can anybody tell me what you mean by sampling? Anybody?
Collection of the data.
Collection of data and doing analysis.
Doing analysis.
What are the things we need to sample or we need to do? We are now talking in the terms of industrial hygienists. Actually, they are the people doing it. But as safety managers, we also should have an idea what they are doing. So can anybody tell me what are the things that we do sample generally? Have you seen people doing sampling, measuring in your workplace?
Noise.
Very good. Noise, very good. Then?
Drinking water testing.
Drinking water sampling testing, very good. Then let us talk about hazards. Noise is a hazard. Drinking water is something good thing. Okay, fine. They are doing sampling of that. Very right. Apart from that, what are the samplings you do? What are the okay, LEX level, soil testing, very good. Then one most important thing you are not telling, you are seeing it daily. Air monitoring. You have personal dosimeters, personal this thing, what is that called? They put it here like on the coverall.
Multiple gas detector.
Multiple gas detectors. Yes. Well, what you are monitoring? What you are sampling? You are sampling the air.
Yes.
Very simple. Air monitoring. Very good. Dust monitoring. Vibration monitoring. They put some belt on the arms for these concrete breakers and all. So any hazard in the workplace is to be monitored. For that, we do sampling. Say, for example, you suspect H2S. So you're doing sampling for that, or the people doing radiography. Anybody here who was exposed to radiography or who knows about radiography testing here in your workplace? Anybody? Nobody.
We know that they do, but we don't know how they do.
They keep badges. Some
Yes,
badges
sir.
on the radiography.
I have been worked in many places where they had two types. One is conventional radiography, and the other type which they did was SAFRAR. So conventional has, based on my understanding and my studies, conventional is the old type, and it will cover the radius in higher range. If they do the
Old
conventional
type means what do you mean? That
Yes.
badge? Badge, yeah?
No, it was no. The new type they are utilizing the SAFRAD. The exposure is within 3 meter only. But the conventional radiography method, it depends upon how much curie you are increasing. The exposure and the range is covering a lot. Say, for example, if the curie is 50 and the range is 150 meters square. Say, for example. But if the SAFRAD, which is if they are doing somewhere, in the busiest plant, like in shutdown plants, they are doing some SAFRAD radiography. They are just barricading the area within 3 meter radius. So they are telling that it will not exposure above this point.
Acha.
Okay, but
Actually,
there is advantage and disadvantage. The conventional was more accurate than the SAFRAD.
Acha.
This is what I learned.
Acha. What somebody else was telling something? Yeah, please.
sir, actually, the unit is curie.
Yeah.
Suppose 1 curie, 10 meter radius, we have to barricade. Okay, so suppose it is exposure limit is 3 curie, so 30 meter. So that way they calculate and they barricade the area and give the signage, and they use that meter. By that they can calculate how many curie that is radiating, and that way they are barricading.
They have the table. That is what he was telling about the conventional radiography.
Yeah, conventional.
So,
I understood this. I am much more concerned about how do they sample? How do they measure the exposure?
They have one specific monitor, sir. I forgot the
Dosimeter.
name.
Dosimeter. Personal
With
dosimeter.
the help of dosimeter.
Okay. Okay, that is where I was interested in. So that is what we are going to discuss now.